Okay, so today we're going over Module 12, so the triangle proportionality theorem, and the objective is students will use proportional ratios to solve for a missing length on the triangle. So we're going to start off with this one. We're going to complete the following proportional ratios. So what we're looking for here is, so look at the ratios already given. So if you look up here where it says AD, this part of the triangle, think of this as the top part of it. DB over here is the lower part. So in this triangle, again, as long as these are parallel, the sides are proportional to each other, which means that the top part is proportional to the top part on the other side. So these two sides, think of it as the two top parts. So you put AD and AE, and then we put DB, and EC is also another lower part. So here, EC. Again, now if you look at side AB, so AB right here, think of A to B is the whole segment, the whole side, not part of it. Same thing with A to C. That's the whole part of the segment. So AB is the whole. And if I look where DB is at, DB is the lower part. So when I set this up, whole part goes with the whole part. So whole is AB, the other part's AC. DB is the lower part, so the lower part on the other side would be EC. And if I look at the last ratio, DB right here is the lower part. AB is the whole. So I want lower part over the whole. So it'd be EC over AC. Okay, now example 2, again, using the same proportions, we're going to solve for the missing side length. So here, the question marks on this segment right here. So I'm going to call that X for a missing part. Okay, so another way you could look at it here is, so you know, this part of the side and this part sort of correspond to each other. And we also know that this part's the whole segment and the 7 is the whole part as well. So when we set up a proportion here to solve for the missing value, think of what they're given over here. They give us, let's think of it as the top part and the whole. Over here, 3 is the top part of this segment and 7 is the whole. So when I set up my proportion here, I was going to set it up as x over 14 equals 3 over 7. And I just want to cross multiply right here. So I'm going to take x times 7. It's going to give me 7x. And I'll take 14 times 3. That's going to give me 42. And I just divide both sides by 7. And I'm getting here x equals 6. Okay, example 3. So the part we're missing here is the whole part. So I'm going to call this part here X. Okay, so let's set up which parts go together or correspond to each other. So I know the two whole parts. So I know this segment and this segment go together. Another thing I know here is that I have this 36. So remember, this is the top part of the segment, which means that it corresponds to this part. But I don't have a value for that. So what I need to do there is, again, I need to solve for this part right here, which gives me, this is going to be 16. And remember, the way I get that is just 28 minus 12 gives me 16. So when I set up my proportion here, I'll take x over 36 equals 28 over 16. And I just cross multiply right here. So x times 16 gives me 16x. And then 36 times 28, that gives me 1008. And I divide by 16 on both sides. So this means that x equals 63. Okay, example 4 says if ED is the midpoint. Oh, sorry, wrong word. So this should be, okay, so delete that word. And it should say mid-segment. The mid-segment of triangle ABC, what can we conclude about the remaining segments? So if we know, if this is the mid-segment, we could say that ED and CB are parallel. So we're going to write that down right here. We're going to say ED parallel to CB. Another thing that happens here when this is a mid-segment, remember these two segments are congruent because E is a midpoint. So here we're going to say AE, so segment, is congruent to segment EC. And the same thing goes for the other side. These two correspond because point D is a midpoint. So we're also going to say that AD is congruent to DB. Another thing right here, you're also going to say that CB is equal to twice ED. Or if you go the other way around, you can also say that ED is half the length of CB. And then some angle relationships right here, we could also mark. So you can also say that angle, this angle right here, these two angles, they're congruent because they're, think of it, they're corresponding. And same thing goes for this over here. So I go this angle with this angle. So again here is again the corresponding angles. Example 5, it says BU is the midsegment of LKN. What is the length of MK? So here we're going to say that MK is equal to twice the length of VU, or 2 times 7, or which is 14. Okay, so here we're looking for the length of JK. So again, this is a mid segment. So again, we're going to say JK is equal to half the length of YW, or half of 10, or gives us 5. All right, so we're done with today's notes.